Okay, question 9. Lily owns 3 confectionery outlets. The table shows the number of each type of cakes. Okay, write down a 3 by 4 matrix P that represents the sale of cakes in each stall. Okay, so I think it makes sense here because it's 3 by 4 sale of cakes. This fourth one, this is like 4 by 4. So I don't really need this fourth one because it's telling me the selling price of each cake. I just want to represent how many sales I made, right? So this tells me this is 30 sales, 30 chiffon cakes were sold outlet A. 20 kaya cakes were sold at outlet A, you know. This is just telling me the selling price of each cake. So I don't need it for my matrix. So for my matrix, I'm just going to write down like this. 30, 40, 20, 20, 50, 16, 35, 45, 24. Like this. Alright. B, write down a 4 by 1 matrix that represents the cost of each type of cake. Okay, so that's over here, the cost of each type of cake. And it's 4 by 1, so it's going to be 4 rows in 1 column. So let's follow that. So maybe 5.5, 7.50, 6.00, 30. Just follow. Okay, so this is P, right, and this is Q. Cool. State the order of P times Q, and so we've done this many times now. This is 3 by 4, and this is 4 by 1. So it's quite clear that P times Q will, therefore, the order will be, since this is 3 by 4, and then Q is 4 by 1, and you can see that the 4s are the same, and so this is going to be a 3 by 1 matrix. So the question says state the order of PQ, so it's simply 3 by 1. Alright, now they say find PQ, so that's quite a natural progression. I'm just going to do it aside over here. So that's D. Okay, so PQ, let's just write it down. We have 30, 40, 20. Okay, there we go. And we've already established that this result is going to be some 3 by 1 matrix. So 3 rows and just 1 column. Now I'm writing it big because I want to write out the full working. So we can see, okay, this is row 1, column 1. So row 1, column 1. So you can see this row moving down. So 30 will align with 5.5, 20 with 7.5, 35 with 6, 10 with 30. And so, it'll be 30 times 5.5 plus 20 times 7.5. And then here, the second row, first column, second row, first column. So that's times 6 plus 12 times 30. Finally, we have the third row, 1 column, third row, 1 column. So we do 20 times 5.5 plus 16 times 7.5 plus 24 times 6 is 24 plus 8 times 30. Yep. And there you have it. You just key it onto the calculator and you get 825 by 1225 and by this. There we go. Alright, part E. Describe what is represented by the elements of PQ. What do all these elements represent? And to answer this question, once again, looking here is tough. I always look at the working. And so over here I have, you can see 30. So 30 is actually, maybe if I use some highlights. Over here, like I said, this 30, right? And then, and that is multiplied by 5.5, which is which is how much you're selling the chiffon cake for. So that makes sense. And then you have this 20 over here, 20 kaya cake, right? And you multiply it by 7.5, which is how much the kaya cake costs. So that makes sense. So actually, what you see is that this whole line here, 35 banana cakes sold for $6, and 10 kueh lapis sold for $30 each. This is the total amount of money made. And all these, see, all these are from outlet A. So really, this is total amount of money made for A. And this is total amount of money made for B. And this is total amount of money made for C. Yep. And so, you can say over here is that the elements, so you can say is they represent the total amount of money. Can you say they sell the price, right? So maybe total amount, it's not really money made, maybe you say total amount of money received, right? Or you can, say from each of the outlets A, B, and C respectively. Respectively, A, B, and C. So immediately knows A, B, and C from each one. There we go.